Hello, welcome back to Ali Khan Maths. In this video I'm going to be doing a full walkthrough of a past Edexcel IGCSE Maths paper. The paper I'm covering is the higher tier paper 2 from the May-June 2019 series exams. Although this is for the Edexcel IGCSE, similar topics and questions repeat in all papers in all exam boards, so this will be a useful video regardless of which exam board you're doing. I'll be covering how to do each question along with some exam technique on how to answer questions most efficiently. The first question in this paper reads, the table shows information about the heights in centimeters of 48 sunflowers in a garden center. We're asked to work out an estimate for the mean height of the sunflowers. So essentially this question is asking us to find the mean from a frequency table. And to do this, the first thing you have to do when the frequency is group frequency is you have to remember to take the midpoint and use the midpoint for all of our calculations. So here the midpoint, which I'm going to call x, is 95, 105, 115, 125, and 135. The reason why it asks us for an estimate is because we use the midpoint of all the groups. We're going to call all of this frequency f, and we're going to take the sum of this sum, and we're going to take the sum of this symbol meaning sigma, or sum of all the frequencies. And when you add this all together, this comes out to 48. And then the next thing which you have to do is multiply the frequency by the midpoint of each group. So you would do 8 times 95 to get 760. 12 times 105, which gives you 1,260. And this gives you 1,725, 1,250, and finally 405. And this is called f of x. And this is called fx because we're multiplying f by x. Now the formula, if you'd like to call it that, for the mean from a frequency table is given as the sum of f of x divided by the sum of f. So we worked out the sum of all the frequencies at the start. It also gives us that in the question when it says 48 sunflowers. And now we need to work out the sum of all of these fx that we've worked out. And when you find this calculation using your calculator, remember this is a calculator paper, it comes out to 5,400. So you plug both of these into the formula and you get 5,400 over 48, which is equal to 112.5 centimeters. And remember centimeters because we're measuring the height in centimeters. Although it gives you that in the answer anyway, so all you have to write down is 112.5. The next question is about constructions. And remember, with constructions, it's always best to use a pencil in case you make any mistakes. However, we're asked to construct a perpendicular bisector, so you might not even need a pencil on its own. You would need a compass, because to work out the perpendicular bisector, you need to draw two arcs. One from the end of the line segment, which must be over half of the line segment in length. So it would look something like this. And you draw an arc above and an arc below the line segment. Keeping the same measurement on the compass, you bring your value from the other point and draw two more arcs above and below. Or, to work out the perpendicular bisector, you simply connect these two lines. And if you'd like to show that this is indeed a bisector, you can write two little dashes here, which shows that these are equal in length. The next question is a sets question, so knowing your sets notation is essential for this one. We're given the universal set as the natural numbers from 1 to 10, and a few of these numbers in A and a few of these numbers in B. The first question, we're asked to write why A intersection B is equal to the null set. What this means is that there are no terms which are common for A and B. So asking us why A intersection B is equal to 0 is simply that there are no terms in common between set A and set B. That's literally all you need to write. It's a one mark question, so there's no point in wasting your time writing anything elaborate. And for part B, we're told that x, any element x, is an element of the universal set. So one of these natural numbers from 1 to 10. But x is not an element of A union B. A union B denotes all of the elements in A and all of the elements in B together. So we're told that this number x that they're talking about isn't in A and it's not in B either. So it might be helpful to first write all the elements in A union B. So this is going to be written in numerical order, counting up. 2, 3, 4, 5, 6, 7, 8, there's no 9, 10. So comparing A union B to the universal set, we can clearly see that the only two numbers missing are 1 and 9, which aren't here, and so those are the only two possible values of x. Now we're given information about a set C. We're told that A union B union C is the universal set. A intersection C simply has 2 in it alone, and B intersection not C, as it's known as, is equal to, and B intersection not C has the elements 4, 6, and 10. So there's a lot of information to process already, and with the addition of a third set, it'll be much helpful. So there's a lot of information to process already, and with the addition of a third set, it'll be much more useful for us to draw a Venn diagram. So we'll do that. Again, this doesn't need to be anything elaborate, it just needs to be something rough so you can help yourself visualize the problem. So you would simply draw 3 circles and a box around it. You might want to make these bigger, but as long as you can see it, and as long as you know what's working out for you. So first, we're told that A union B union C is equal to the universal set. So what this means is that all of these numbers must be in these 3 circles, and tells us that there's nothing in this box outside of the circles. So it might just be helpful for you to write no elements to help remind yourself of that fact. Next, it tells us that A intersection C is equal to 2. So we look and consider the area A intersection C, which would be this circle, not really a circle, but this segment over here. But now we have to try and work out whether this element 2 is located in this region or this region, because both of these regions are encompassed by A intersection C. However, recognize that this region is also present in B, and we know that B doesn't have the element 2 in it. Therefore, the only place 2 is present, the only place 2 can be present, is in here. Next, we know that B intersection not C refers to everything except for C. So if we covered up the circle, which means C, not C would refer to every other area. We know that B intersection not C is 4, 6, and 10. So this means 4, 6, and 10 is present wherever 4, 6, and 10 are present wherever B, this circle, intersects everywhere which isn't C. And this only shows us 2 regions, the smaller one over here and the main region for B. So now again we have to work out, where do 4, 6, and 10 go? Do they go in this region or in this region? Notice that this region is also present in A. Looking back at A, we see that the only elements in A are 2, 3, 5, and 7. Therefore 4, 6, and 10 aren't present in A, so they can't go in there. The only place where 4, 6, and 10 can go are inside this region. So that's all of the basic information that we can get just from these 3 rules alone. But now, actually thinking about it more, we can work out the rest of the elements and where they go in this Venn diagram. First of all, we're told that A intersection C is equal to just 2. It only has the element 2 in it. And we know that the rest of the elements in A include 3, 5, and 7. However, because the only element in A intersection C is 2, this means that 3, 5, and 7 aren't present in C. That means there's no 3, 5, or 7 in any of this region with C in it. And we already know, looking at B, that B neither has 3, nor 5, nor 7. So 3, 5, or 7, they can't be present in this circle. They can't be, so 3, 5, or 7 can't be present in this circle. They can't be present in this circle either. Meaning the only place where 3, 5, and 7 can be present are in this circle, which is the main A region. Next, consider the information we got from part B. We know that 1 and 9 are the only 2 elements which aren't members of A union B. This means that there's no 1 or 9 present in any of these 2 circles over here. Remembering from this first piece of information we're given, all of the elements in the universal set, all of these 10 elements, they must be present within these 3 circles. And we know that 1 and 9 cannot be in any of these 2 circles, meaning that 1 and 9 have to be present in C. Finally, we mustn't forget about one number which we haven't written yet, and that's 8. We know that where B intersects not C only has the numbers 4, 6, and 10. So cover this region, C. Wherever B intersects this has to have the numbers 4, 6, and 10. So there's no mention of 8 in this region, or in this region either. But we know that 8 is still a member of B. So this leaves only one more region inside B where 8 can be present, and that is the region where B intersects C. 8 cannot be present in the center because there's no 8 in set A, meaning 8 has to be inside here. So now we've distributed all of these numbers amongst the sets, and we step back and look at all of the members of set C now. We have C is equal to 1, 2, 8, and 9. Remember, convention is that we always write the elements in ascending order. This is your final answer for this part of the question. Question 4 asks us to find the volume of the cylinder which we're given the diameter and height for. Whenever I see a volumes question, I always find it easiest, regardless of how simple it is, to draw out a very, very quick sketch just to help me get an idea of how it's going to look like. Even if it's just a bad sketch, it doesn't matter because it's only to help me understand it. However, it also helps the examiner and shows them that you have some idea of what you're talking about. So we know that this height is 20 centimeters, is what we're told. And the diameter of this cylinder is 14 centimeters. This means that the radius must be half of the diameter, so it's 7. Now remember that the volume of the cylinder is given by the formula pi r squared h. This is also present on your formula book, or this is also present on the formula sheet at the front of the paper, so there's no need to actually memorize this, but it can make it useful when you're actually using it. So now plugging in the numbers we have, the volume is equal to pi times 7 squared times 20, which is equal to 980 pi. And this is approximately equal to, when you put it in a calculator, 3078.76 centimeters cubed. Remember, 70 centimeters cubed is our unit for volume when centimeters is being used. But realize that the question asks for 3 significant figures, so you must round this, looking at the fourth number, to 3080 centimeters cubed. And this is our final answer to 3 significant figures. So for this fifth question, we're given quite a lot of information to process at first. We're told that Josh buys and sells books for a living. He buys 120 books for £4 each. Half of the books he sells for £5 each. He sells 40% for 7, and he sells the rest, so whatever's left, for £8 each. And for part A, we're asked to work out Josh's percentage profit. So first of all, I would write the formula for percentage profit. Not really formula because it's quite intuitive when you think about it. But it is the selling price, so what you're selling the items for, minus the cost price, which is what you originally bought them for, all over the cost price, because since it's a percentage, you want it as a proportion of what you originally bought it for, times 100 to get into the percentage form. So we can see that we need to work out 2 main pieces of information from all that we're given. We need to work out the selling price and the cost price. So first we'll work out the cost price, because this is the simplest. We're told that he bought 120 books for £4 each. So multiplying them together gives us £480. This is the cost price, which is how much Josh bought the books for himself. Then we use all of this information, these 3 lines, to work out the selling price. We know that he sold half of the books. The total books are 120, so half of the 120 books he sold for £5. And then he sold 40% of these 120 books for £7, before finally he sold whatever's left at £8 each. So first of all, 1/2 times 120 is 60, so this is quite simple to work out as £300. 40% times 120 works out to 48 books that he bought for £7 each, coming to £336. And whatever's left would be the total 120 minus 60 books minus 48 times 8, which brings us to £96. And then to find the total selling price, we just add all of these values together. So 300 plus 336 plus 96, which gives you a value of £732. So now we've worked out the total selling price and the total cost price. So we can work out the percentage profit pretty easily by putting it into this formula. So we take the selling price, 732, and subtract 480. And this is all over 480 times 100. Putting it into your calculator, you'll find that you're left with 52.5% as the percentage profit. This is a 5-mark question, so quite hefty in terms of marks, so it's important you get this right. The next part of the question tells us that one book that Josh owns had a value of £15 on the 1st of May 2019, and this value of this book had increased by 20% in the last 1 year. And we want to find the value of the book on the 1st of May 2018. So the 1st of May 2018 to the 1st of May 2019 is 1 year. So we know that this has increased by 20% since this date. And we want to find the value of the book on this date, also known as the original value, before any change. And we're going to say this is equal to 100%, because the original value is 100% of the original value. The new value, i.e. the value on the 1st of May 2019, is an increase in 20%. So you had the original 100% plus an increase in 20%. So this must be equal to 120%. And we're given an exact value for this, which is £15. So if we know that £15 is equal to 120%, we want to find 100%, which is the original value. So to do this, first I'll divide both sides by 120, and this will give you 0.125 pounds equal to 1%. Then to find 100%, you simply multiply both sides by 100. So you have 12.5 or £12.50 equal to 100%, which is the original value that we need. That's your final answer. Again, a 3-mark question, quite significant in terms of marks. And you wouldn't really expect this to be 3 marks, because if you understand the simple concept. Question 6 is a question all about similar triangles. So it's really important to understand how scale factors work. The scale factor is how much you would multiply each length in the smaller triangle to reach the length in the larger triangle for the corresponding sides when they're both similar. So here the scale factor, which is usually given by k, and that's what we're going to use here, is equal to 15 over 6. The ratio between the side in the larger triangle over this corresponding side in the smaller triangle. Simplify this equal to 5 over 2. Might be worth writing that this is the scale factor going from the triangle ABC to the triangle DEF, because you could also work out the scale factor from a reversed fashion, which tells you how much smaller this is from the larger triangle. So to find DF, we multiply the original, we multiply the scale factor by the smaller corresponding length, which is 4.2. We worked out the scale factor as 5 over 2 times 4.2, and this is equal to 10.5 centimeters. We could do the same method with using scale factors for part B, but to show off the other method of how you could do it, I'll just use the ratios between the sides themselves. So you take the ratio between the smaller side and the bigger side, which are corresponding between the triangles. This would be BC over 19.5. And this ratio has to be the same as the ratio between any two of the other corresponding sides between the two triangles. We'll use 6 and 15. So BC over 19.5 has to be the same as 6 over 15. To get BC on its own, we multiply both sides by 19.5 centimeters to get 6 over 15 times 19.5, giving us 7.8 centimeters as the value for BC. We're given another longer word problem for question 7. We're told that 30 students in a class had a mathematics test. The mean mark, also known as the average, for these 30 students was 26.8. However, 13 of the 30 students in the class are boys, and the mean mark for all of the boys was 25. We are asked to find the mean mark in the text for all of the girls. So I'm going to start this first of all by writing the formula, not really formula, but the definition of the mean, which would here in this context simply be able, which would in this context simply be equal to the total mark over the total number of students. So let's start from the top and use the information that we're given. We're told that the mean for 30 students, these include both boys and girls, is equal to 26.8. However, we can use this to work out the total mark, because if we put the mean into there, 26.8, and multiply by the total number of students, we're left with the total mark. So the total mark across all test papers would be equal to 26.8 times 30, which is 804. Now we'll handle each of the boys and girls separately and handle all of that data using the total mark to work out the total mark of the girls. So we need, for the mean mark, we need to find the total mark for the girls divided by the total number of students, in this case, the total number of girls. We're told that there are 13 boys in the class, and this implies, seeing as we're not given any more information in the question, that the rest of the students in this class are 17 girls. So we have the total number of students, or the total number of girls here. So we just need to find the total mark for all of the girls. To do this, we have to take the total mark and subtract away from that the total mark of all of the boys. So we handle all of the data with the boys first. We know that the mean for 13 of these boys is equal to 25. Therefore, the total for 13 is equal to 25 times 13, which is equal to 325. So like we mentioned earlier, the total mark is equal to total girls plus the total for all of the boys. This means 804 is equal to the total of the girls, which we'll call capital G, plus 325, meaning that the total for all of the girls is equal to 479. So now we have all of the information we need to work out the mean mark of all of the girls. We have the total number of girls, we have the total mark of all of the girls, so the mean has to be equal to the total mark, 479, over 17, which is the total number of the girls, which gives you 28.176, quite a long string of numbers. But we want this to three significant figures, so we must look at the fourth number, which is a 7, meaning that this rounds up the 1 into 28.2 to 3 significant figures. The next question asks us to generally change the speed of x kilometers per hour into a speed which is in meters per second. So we're going to need two key pieces of information which you have to come into the exam knowing, and some of which you might already know this already. 1 kilometer is equal to 1,000 meters, and 1 hour in terms of seconds is equal to 60 minutes times the 60 seconds in each minute, which is 3,600 seconds. Say we have a speed in x kilometers per hour. Remember that speed is distance over time. So this would be the same thing as x over the number of kilometers over the number of hours, which is just equal to the x number of kilometers over 1 hour, which is equal to the x number of kilometers over 1 hour, because the speed is in kilometers per singular hour. So x kilometers, regardless of the value of x, would be written as 1,000 x meters, because there's 1,000 meters in 1 kilometer. So you replace the kilometers with 1,000 meters to give you 1,000 x meters. And again, 1 hour is equal to 3,600 seconds. So if we were to write x kilometers per hour, this would be written as 1,000 x meters over 3,600 seconds. We can take out the m over the s from this fraction because that's equal to our unit meters per second, giving us 1,000 x over 3,600 meters per second. You can simplify this fraction quite simply to give you 5 over 18x meters per second, which is our answer. Question 19 is a simultaneous equations question. Luckily, only linear simultaneous equations, meaning we don't have anything with squared terms or anything like that. So whenever you solve simultaneous equations, you need to make sure to set out your work really clearly, because with simultaneous equations, often if you get the final answer wrong, you can still get quite a lot of marks, or most of the marks at least, from your working out. So you need to make sure it's all clear and easy for the examiner to understand. So you can start with that by labeling each equation, equation 1 and equation 2. What you want to do is you want to find a way to cancel one variable, leaving you with an equation in terms of the other variable only. So we could multiply the first equation by 3 and then cancel the x's, but it seems a lot easier to me to multiply the second equation by 2 and cancel the y's. So that's exactly what we'll do. Multiply equation 2 by 2, which gives us 6x minus 2y is equal to 32. And of course, we have equation 1 as x plus 2y is equal to minus 0.5. That's equation 1, and we'll call this new form of equation 2 2 dash. So to cancel out the y's, we add these together, as this is positive and this is negative. So we have 1 plus 2 dash. This is equal to 7x equal to 31.5. To get x on its own, we just divide both sides by 7, giving us x is equal to 4.5. Now that we have one value of x, we can substitute this value of x into any of these equations to get our value for y, which corresponds with this value of x. So I'm going to choose equation 1. So I'm going to choose equation 2, which would mean 3 times 4.5. You just replace any x with 4.5 minus y is equal to 16. This means that 13.5 minus y is equal to 16 minus y is equal to 2.5, and thus y is equal to minus 2.5, and that is your value for y. But always remember to check your answers into the second simultaneous equation or the second linear equation to make sure that they work out correctly, and that basically ensures that you've gotten it right. So substitute both values into equation 1 as your form of checking. So that means 4.5 plus 2 times minus 2.5 is equal to minus 0.5, meaning 4.5 minus 5 is equal to minus 0.5, and this is true. Therefore, you know that your two answers are correct. X is equal to 4.5 and y is equal to minus 2.5. Question 10 involves both finding the equation of a straight line and also using inequalities from straight lines themselves. We're told that the straight line L has a gradient of 5 and passes through the point with the coordinates 0, minus 3. We're asked to write down an equation for L. There's two methods of doing this, and the first is using the gradient point formula, which is y minus y1 is equal to m, also known as the gradient, times x minus x1. And this is when you're given the gradient and when you're given the coordinates of one point, where this point can generally be x1 or y1. So substituting these numbers in, you have y minus y1, which is minus 3, is equal to m, 5, times x minus x1, which is 0. The two negatives cancel out, giving us y plus 3 is equal to 5x, and you subtract 3 from both sides, giving you the equation, the general mx plus c form of y equals 5x minus 3. Alternatively, although I like this formula and I think it just makes it seem a lot more easier, you can use another way where you write the general formula of a line as y equals mx plus c and substitute your gradient instead of m. So you have y equals 5x plus c before you sub in the point that you're given. So you sub in 0 minus 3 to give you minus 3 is equal to 5 times 0 plus c, which means that c must be equal to minus 3 before you sub your m and your value for c into the formula to give you y equals 5x minus 3. Both methods are correct. Both methods are really just the same thing, just appearing a bit different. And in this case, both are approximately the same speed as each other. Now question 10b shows us a region, which is shown shaded in the diagram, region R, and it's bounded by 4 straight lines. And we can see that it's a square. We're asked to write down the inequalities of these lines, which define R. So firstly, it's important to notice that all of these lines are solid lines. And this means that each inequality is either greater than or equal to or less than or equal to. If it was dotted lines on the diagram, this would mean it's just greater than or less than. But because they're solid lines, we know that it has to have an equal to for each of these 4 lines. So first you have to forget that these are inequalities and just work out or look at the equations of these 4 straight lines in themselves. So this line, which would extend something like this, is simply equal to y is 1, y is equal to 1. The vertical line here, because these lines are vertical and horizontal, it's quite easy to work out their equations, is simply equal to x is equal to 2. Similarly, we have y is equal to 3, and x is equal to 0, because this is just the line on the y-axis. Now you have to look at the region which is shaded in relation to each of these lines. So we'll start off here. We have the line x is equal to 0 here, but the region that's shaded is to the right of x is equal to 0, meaning every x value here is greater than x is equal to 0. Remember that because it's a solid line, that means it has to be equal to as well, meaning that this region has been enclosed by x is greater than or equal to 0. Contrastly, the right line on the right here is x is equal to 2, but the shaded region is to the left of this line, i.e. it's to the left of this line, meaning it's less than this line's value of 2. So it's x is less than or equal to 2. For y equals 1, the shaded region is above y is equal to 1. So this must be y is greater than or equal to 1. And the shaded region is below y is equal to 3. So it has to be equal to or less than 3. And those are your 4 inequalities. Question 11 is one which is all about standard form. Again, in the context of a football question, you'll find that paper 2 has quite a lot of word questions. So it's important to make sure to read every question properly and make sure to answer exactly what they're asking you for. So we're told that this table gives the average crowd attendance per match of 5 football clubs in one season. We have to find the difference between the average crowd attendance for Barcelona and the average crowd attendance for Monaco first. So we go to the table and simply look at these two numbers. We know that for Barcelona, it's 7.7 times 10 to the 4. And this is, from this we subtract 9.5 times 10 to the 3. It's helpful that they choose Barcelona and Monaco as the examples, so it's quite easy for you to tell which one would be bigger. You can do this with a calculator quite easily before you convert your answer back to standard form, but there's a really easy way to do this by hand, where you factorize out 10 to the third power. So we're left with 7.7 times 10. If you multiply these together, you can see it makes sense because the 10 to the 3 is added to the 10 to the 1 to give you 10 to the 4 minus 9.5. And working out the inside of this, you know you'd have 10 to the 3 times 67.5. But this isn't written in standard form. because for standard form numbers, they have to be between 1 and 10. So to do this, you would divide this by 10 and add that power onto the end here. So in standard form, this is written as 6.7 times 10 to the 4. And that would be your answer for the difference. 6.75 times 10 to the 4. For part B, we're given a statement from Antonio, which says that the average crowd attendance for Chelsea is approximately 50 times that for Oxford United. So although there's no mention of Chelsea being a tin pot club with plastic fans filling these crowds, we are given the crowd numbers, which is 4.2 times 10 to the 4. And this guy Antonio says that this is approximately 50 times that for Oxford United. So to answer this question, you simply have to prove him right or wrong using calculations. So we'll take the Oxford United attendance, which is 8.3 times 10 to the 3, and multiply that by 50. And quite simply, this would give you, so we have 8.3 times 10 to the 3 is multiplied by 50. But you can write 50 as 10 times 5. What's nice about this is that the 10 to the 1 power, when you multiply it with the 10 to the 3, simply adds 1 to the power to give you 10 to the 4. And 8.3 is multiplied by 5 to give you 41.5 times 10 to the 4. However, this isn't written in standard form. Again, you have to divide by 10 here and add 1 to the power to give you 4.15 times 10 to the 5 as this value written in standard form. If you do it using a calculator alone, you'll find that this result, the original calculation, will give you this number. And to put that into standard form, you can see you have to go back 1, 2, 3, 4, 5 decimal places to give you 4.15 times 10 to the 5. You can take your pick on what to do, but this first method definitely shows your understanding to the examiner. But now we have to compare this to the value of the average crowd attendance for Chelsea to see whether Antonio is right. We can see that the average crowd attendance for Chelsea is 4.2, which is close to 4.15, but it is 10 to the 4, whereas ours is 10 to the 5. This means Antonio is not correct. He's wrong because... So to explain my answer, I've written a simple line of reasoning using the calculation which you've worked out. In the mark scheme, as it's a 2-mark question, it asks for a no for 1 mark, and then any form of justification using your calculations for another mark. This might not be the only way you do this. You could divide Chelsea's attendance by 50 to find the number which isn't really near Oxford United's attendance, but this is just one way. Part C is another percentage change question, which isn't related to the earlier parts of the question. However, this is different to the one we did earlier in that we're not given any specific value, we're only given percentages alone. For this question, the key is to remember that you can also write percentages as decimals. So we're told that the cost of a ticket to watch Cyprian United increased by 15% before being decreased by 8%, and we have to work out the overall percentage change. So we'll say that the original price the original price of the ticket is equal to 100%, but as a decimal, this is equal to just 1. If it's increased by 15%, this means that the new price was equal to 1.15 because 15% is written as 0.15 as a decimal, and that's simply added to the original 1. But this was decreased by 8%. And this 8% applied to this new 1.15. So we have to multiply this by 0.92 because the original 100%. We have to multiply this by 0.92 because a decrease of 8% would be taking 100% minus 8%, leaving you with 92%, which is written as 0.92 as a decimal. So that's why we multiply the 1.15 by 0.92. And once you do this, this gives you 1.058. We want to find the percentage change overall between this new price of the ticket compared to the original price of the ticket. So we simply subtract the new from the old. You get 1.058 minus 1 is equal to 0.058. But the overall percentage change is always written as a percentage. So although at the start we change from percentages to decimal, we have to remember to go back from decimal back to percentages. And to do this, you multiply by 100 to give you 5.8% as the total overall percentage change. Question 12 is a question which involves a lot of trigonometry to find the answer. We're given this trapezium ABCD with a singular angle given and two lengths, and we want to calculate the perimeter of the trapezium. Remember that the perimeter is the sum of all of the outside sides, so the perimeter would be equal to AB, which is 16.7, but we won't work with the lengths right now because some are still unknown. It would be AB plus BC plus CD, finally plus AD. So now we must compare the lengths that we have and try and work out the lengths which we don't have. We definitely have AB, so I'll just put a star over it, and we definitely have BC, but we're not given CD and we're not given AD, so we have to work those out ourselves. We'll start with AD. To work out AD, I will draw a construction line, which is an altitude from C down to the base to form a right angle triangle. I would call this point of intersection X, and this splits AD into two smaller lines. We've split it into AX plus XD. We can see that AX is equal to 21.2 centimeters because it's directly opposite BC, which is the length of the top side. And similarly, CX might be useful for us to note that it's equal to AB, which is 16.7 centimeters. So now to work out AD, we have AX, but we don't have XD. So we need to work out the value of XD. Because we formed a right angled triangle, the triangle CXD, we can definitely use some trigonometry, seeing as we have one angle and we have one side. So we want to find XD, and we have CX, and this means that in relation to this angle, we have the opposite, and we're looking for the adjacent. So we're dealing with an angle opposite adjacent, so we're going to be using tan, and this means that the formula for using tan is that tan x is equal to the opposite over the adjacent. Our x angle is 43, so tan 43 is equal to opposite 16.7 over xd, which is the adjacent, and you can rearrange to give that xd is equal to 16.7 all over tan 43. You might want to simplify here, you might be tempted to, but it's usually good to simplify or round as late as possible in the question, because it'll make sure that it doesn't throw off any of our calculations if we round too early. So now we have XD, meaning we have the value of XD and we have the value of AX. We have the total AD, so that's another unknown which we've now found. Meaning the last unknown, Meaning the last unknown which we have to find is CD. So to find CD, which is the hypotenuse of our right angled triangle, we could use Pythagoras' theorem, but we're using trigonometry already, so we might as well use some more. We have our one angle X, we have the opposite, but we want to find the adjacent. So remember that the value we're using, or the ratio we're using, is sine of X, and this is equal to the opposite over the hypotenuse. Because we're dealing with the opposite and hypotenuse, that's how we know to use sine from the definition of sine. So now let's plug in what we have. Sine 43 is equal to 16.7 over the hypotenuse CD, and multiply, divide, rearrange to give 16.7 is equal to sine 43. If you're wondering, the intermediate step here is that CD times sine 43 is equal to 16.7. Then to get CD on its own, you simply divide both sides by sine 43. We've now worked out all of the unknowns in this question, We've now worked out all of the unknowns in this question, meaning we have all of the information required to work out the total perimeter. We said the perimeter is equal to AB, which is 16.7, plus BC, which is the length they give us, 21.2. This is equal to, or this also must be added to CD, which we've worked out as 16.7 over sine 43 added to AD, which is equal to AX plus XD, which is equal to 21.2 plus XD, which is 16.7 over tan 43. So this is our expression for the perimeter. Adding this all together in your calculator, you are given 101.4954 long number, and we want our value in 3 significant figures. So we look at the fifth number, it's a 4, meaning we have to round down. So this is approximately equal to 101 centimeters to 3 significant figures. And that's our answer. Surprisingly, this question is only 4 marks, even though it uses quite a lot of skill. Question 13 goes through a cumulative frequency table. We're given a table showing information about times taken in minutes for 80 taxi journeys, with all this information on a table with simply frequencies written out. And we have to complete the cumulative frequency table for part A, which is only worth 1 mark. So to do this, we just add each number as it comes along. I've made a previous video detailing how to do cumulative frequency tables and graphs in detail, which you can watch by clicking on the icon at the top right corner of your screen for more information. So first of all, between 0 and 5 we have 7, and the cumulative frequency from 0 to 10 is 7 plus 10, which is 17. Similarly, from 0 to 15 goes to 17 plus 12, which is 29 I should say. And you continue adding on all along in the same fashion to give you 48 and then 66 before you finally end up at 80. A way to check if you're doing it right is if you end up at the original number which you're given. We're given that it's 80 taxi journeys that the table is giving information for, and our cumulative frequency does end with 80, so we've not made any simple mistakes. Part B asks us to draw a cumulative frequency graph on the grid opposite. So to do this, we plot all of our points for time taken and cumulative frequency before using our graph to answer some questions about median and interquartile range. Cumulative frequency, although written in group frequency form, is always plotted from the upper bound or the upper limit of the group. So at time taken 5, our cumulative frequency would be equal to 7, as written here. Next, for 10, it would be equal to 17, and you would continue plotting these points onto this whole curve. Now we have to connect all these points together and plot the cumulative frequency curve. Because the cumulative frequency starts with the group 0 to 5, we have to join the first point with the origin at 0 in a completely straight line before joining the rest of the points in a smooth curve, as relatively smooth as you can get it. So although definitely not perfect, it should do the job. Remember that cumulative frequency graph usually has an S shape, so although not distinct, you can see that the graph begins to steepen its gradient before flattening out again very slightly. We want to use this graph to find an estimate for the median. So to do this, we have to think about what position the median value is going to be at. So the median value is always going to be at the position of the total of all of the frequencies divided by 2. So in this case, it would be 80 divided by 2, which is equal to 40. So from this, we go to our cumulative frequency axis, which is the y-axis, and we move to 40 before drawing a line across to our cumulative frequency curve. Then we draw a line down to the x-axis from the point of intersection, and this should give us a value on the x-axis for the time taken. Each small box is equal to 0.5, because there's 10 boxes for every 5 jumps in minutes. So this means this is equal to 18 minutes when you read it off. To find the interquartile range, we have to find the position of the upper quartile and take away from that the lower quartile. Each quartile is the position at the different quarters of the total frequency. Starting with the upper quartile, the position of this is given by 3/4 times the total frequency of 80, which is 60th. So this is the 60th position. Going back to our cumulative frequency graph and drawing a line across from 60, you can see that this reaches this point approximately before we draw it down and read off our time taken value. So reading this value, we find that it's equal to 23.5. So the upper quartile is equal to 23.5. Similarly, for the lower quartile, we take 1/4 times the total of 80, which is equal to the 20th position, before reading across to the 20th position. And again, back down to the x-axis. This gives the lower quartile as 10, 10.5, 11, 11.5. So to find the interquartile range, we subtract the upper quartile, take away the lower quartile, which gives us 23.5 minus 11.5, which is equal to 12 as your answer. And this mark scheme does support if your graph does look a bit different, as it gives a range of values from 9 to 13. Question 14 gives us two vectors, the vector going from A to B and the vector going from C to B, and we're asked to find the magnitude of the vector which would go from A to C. So to do this question, I would draw a diagram, a quick sketch of these two vectors going from A to B. So I would say point A, I would just put somewhere around here, and I know that to go to point B, it goes across 6 approximately, and going down 9, negative direction, which means that point B would be found somewhere around here. And the vector goes in the direction from A to B. For any point C, to get to B, we have to go across 1 and up 3, meaning C would be found somewhere around here. Again, this is not to scale whatsoever. This distance would be 1, and this distance would be 3, which brings you to from C to B as your vector. And you want to find the magnitude of the vector going from A to C. To find the magnitude of a vector, we simply use Pythagoras' theorem using right-hand triangles to find the magnitude as we would find any other length. So we construct the right-angled triangle. We use the two lengths or magnitudes of, we use the information we're given about each vector. So we know that because the total distance from A to B is 6 in the x direction, and from C to B is 1, this means that this must be equal to 5. So this adds up to 6. And similarly, this is equal to 9, and this is equal to 3. This must be equal to 12. We want to find AC. So using Pythagoras' theorem, we have 5 squared plus 12 squared is equal to AC squared, and this would give you AC squared is equal to 169, and AC is equal to 13. This is the magnitude of AC. You might just recognize that this is a Pythagorean triple, so you would get 13 straight off the bat, giving you 13 as your answer. Question 15 is an algebra question where we have to make x the subject of this formula. We're given y is equal to the square root of 3x minus 2 and over x plus 1. So to do this first, we want to get all of the x's on one side alone. And we would start by squaring both sides to give y squared is equal to 3x minus 2 over x plus 1. Multiply both sides by x plus 1 in order to remove this fraction. And then expand the brackets to distribute the x. This is equal to 3x minus 2. Move all of the x terms onto one side. So you would have y squared x minus 3x is equal to, and then move the y squared term onto the other side to leave all of the x's on one side. To get x on its own, factorize it out from this expression. Give x times y squared minus 3 is equal to minus y squared minus 2 before dividing both sides by y squared minus 3 to leave just x on one side, meaning that you've made x the subject of this formula. And that is your answer. Question 16 is a Surds question, giving us a fraction written in square roots, and we're asked to write it in the form a plus b root 2 in order to give the value of a and the value of b. So first, we'll start with manipulating this fraction as much as we can before comparing it to the general form at the end. We have 4 plus root 8 all over root 2 minus 1. Now notice that 4 plus root 8, in particular root 8, can be written as root 4 times root 2, which is 2 root 2. So we can simplify this. But we want to remove any square root from the denominator in order to get this to a form where we have integers without any fractions. So to do this, we need to rationalize the denominator by multiplying the top and the bottom by root 2 plus 1. This gives us in the numerator 4 plus 2 root 2 times root 2 plus 1. In the denominator, root 2 minus 1 times root 2 plus 1. This is the difference of two squares in the denominator. So expanding the numerator, we're left with this expression before we work on the difference of two squares in the denominator, which is root 2 squared minus 1 squared. This is where anything in the form of a plus b, a minus b can be written as a squared minus b squared. This can be written as 6 root 2 plus 8 in the numerator all over 1, which gives you 6 root 2 plus 8. Now comparing this to the a plus b root 2 form, we compare the coefficients of the like terms. So the constant term is a, and here the constant term is 8, meaning a must be equal to 8, whereas the term in front of the root is b, and here the term from the root is 6, meaning b must be equal to 6, and this is our answer. Question 17 is quite a tough proportionality question. We're told that y is directly proportional to the cube of x. This means that y must be equal to some constant of proportionality k times x cubed. We're also given the information that y is equal to 20h when x is equal to h. So we'll also write that down. Y is equal to 20h. So to work out a formula for y in terms of x and h, as the question is asking, we have to use both of these values. We have to use both of these expressions we're given for y. So when x is equal to h, if you substitute this into the original, we are given y is equal to kh cubed, and this is equal to 20h because y is equal to 20h when x is equal to h. To find a formula for y in terms of x and h, we want to find a value for the constant of proportionality k. To do this, we divide both sides by h cubed to get k on its own, which gives 20h over h cubed. However, the h in the numerator cancels out the h in the denominator, so we have 20h. So we have 20 over h squared as our value for k. So put this back into our original equation for the proportionality, giving us y is equal to 20 over h squared times x cubed as our answer for part A. Part B asks us to find x in terms of h when y is equal to 67.5h. So with this value for y, we can substitute this back into the formula we have to find that 67.5h is equal to 20x cubed over h squared. Now to remove the denominator, to get x on its own, we multiply both sides by h squared to give 67.5h cubed is equal to 20x cubed. Then divide both sides by 20 to get x cubed on its own, giving 67.5h cubed over 20. And to get x on its own, we take the cube root of this expression, which is 67.5h cubed over 20, and the cube root of all of this. The question asks us to give your answer in its simplest form, and you might think you can't simplify further. However, this can be written as 67.5h cubed, 67. However, this can be written as, 67.5 over 20 can be simplified to 27 over 8, with the h cubed now taken outside of the fraction. And taking the cube root of each of these in turn, we have the cube root of 27 over 8, which is 3 over 2, and the cube root of h cubed, the cubed cancels out, leaving us with 3 over 2h, which is our final answer in its most simplified form. Question 18 gives us a solid cuboid, and we're told that the total surface area of this cuboid is a centimeters cubed for some a. We're asked to find the maximum value of a. The reason why we're asked to find a maximum value is because each of these three lengths are variables x. They could be any length, so there are multiple options for the surface area a depending on these values of x. We're asked to find the maximum volume of that a. First of all, we should write an expression for the surface area of this cube. This can be done by finding the area of three faces using each pair of different lengths before multiplying each of them by 2 to get the total surface area. So this would be 2 times x squared, because this x squared represents the bottom face and the top face, plus 2 times 12 minus 3x times x. This represents this side face and the opposite side face, plus 2 12 minus 3x times x, which in this case represents this face nearest to us along with the opposite version. Simplifying, this gives us 2x squared plus 2 times 12x minus 3x squared plus 2 12x minus 3x squared. Expanding the brackets further, we're left with 2x squared plus 24x minus 6x squared plus 24x minus 6x squared. And then collecting all of these like terms, we are left with minus 10x squared plus 48x, which is equal to a, the total surface area of the cuboid. But we want to find the maximum value of a. Usually, when we're given a quadratic and we're trying to find the maximum value of something, it can be useful to draw a really quick sketch of the graph of that function. This might seem a bit unrelated at first, but if we graph the function of the surface area minus 10x squared plus 48x, it might look something along these lines. We can see that because we have a negative value for the x squared coefficient, the curve is facing downwards. So the turning point here is the same as the maximum point because it's the highest value that the curve can take. Remember, to find the turning point of a quadratic function, you must be able to complete the square for that function. So first we take out the factor of minus 10 to give us x squared minus 4.8x. And then rewrite this in completed squared form, which would be x minus 2.4 squared minus 2.4 squared. And this is all, of course, multiplied by minus 10. Now you distribute the minus 10 to give minus 10 times x minus 2.4 all squared plus 57.6. which is the function of the surface area A written in a completed squared form. To get the maximum value of A, we want to make this part with the variable x as low as possible. And this can be done where x is equal to 2.4. When x is equal to 2.4, 2.4 minus 2.4 goes to 0, and multiplying by 0 cancels out this whole part of the expression, leaving us with a maximum value of 57.6. And this is the maximum value of A with centimeters squared because it's an area. Question 19 gives us a quadrilateral ABCD, telling us that the area of one of the triangles ACD is 250 centimeters cubed. We're asked to calculate the area of the quadrilateral, the total larger quadrilateral, and our answer must be to 3 significant figures. First of all, just looking at this question, we can see that we have a triangle formed, triangle ABC, along with the triangle ACD. We're given 2 of the angles for triangle ABC, and we can use that to work out this missing third angle, which would just be 180 minus 95 minus 47, which is equal to 38 degrees. It's always a good idea to look for similar triangles when seeing triangles in any question, because it makes solving it using scale factors quite easy, but we can clearly see that these triangles are definitely not similar to each other. We're going to start by recalling the trigonometric formula for the area of a triangle, which is given by 1/2 AB sine C, where AB are any two sides, and sine C is the angle opposite the third side, which we haven't used. We can apply this formula onto this triangle ACD to work out a missing length. So we set the area of this triangle ACD, which is 250 centimeters cubed, equal to 1/2 AB sine C. This equals 250. First of all, we multiply both sides by 2 to get rid of the fraction. So we have that AB sine C is equal to 500. And now we can label the sides in our triangle corresponding to this AB sine C, to whichever ones we choose. Because we're given only one angle, this angle must be the angle which we use in sine C. So that means this is angle C, and this must be the side C opposite that. And we can call either of these A or B. I'm going to call this side A and this side B. So now putting this into the formula, we have A times 26, or 26 times side AC times sine of 39 is equal to 500. And dividing both sides by 26 sine 39, we get AC is equal to 500 over 26 sine 39. Similar to the question earlier, I'm going to leave it in this exact form because rounding off or simplifying too early can result in an inaccurate answer. Now we can use this length AC that we've worked out to work out another length in triangle ABC, which will allow us to use the AB sine C formula again to work out the area of the second triangle. The way we're going to work out another length in triangle ABC is by using the sine rule, which is given as A over sine A is equal to B over sine B is equal to C over sine C, where angles and sides A and A, B and B, and C are opposite to each other. We've worked out AC, so we'll use that and put that over the sine of 95 for the first part of the sine rule. So this would be 500 over 26 sine 39 all over sine of 95 is equal to, and now we must use any other side and angle combination. Since we've got two other angles, we can use either of them with either sides, but I'm going to use AB and put this over sine 47. So we've worked out by multiplying both sides by sine 47 that AB is equal to 500 over 26 sine 39 over sine 95 times sine 47. And this is our expression for AB. To find the area of the quadrilateral, ABCD, we take the area of triangle ABC plus the area of triangle ACD, which were given in the question, as 250 centimeters cubed. To find the area of triangle ABC, we'll use the half AB sine C formula. So we have 1/2, and we can choose this value. We can choose side AC, which we worked out as our A value. So this would be 1/2 times 500 over 26 sine 39 times B, which we'll use AB for, which is 500 over 26 sine 39 all over sine 95 times sine 47 multiplied by sine of C, which will be sine 38, as this is the only, which will be sine 38, as this is the angle opposite the only side which we haven't used. Sine 38. And of course, to this we have to add the area of triangle ACD, which is given as 250. Putting this all into our calculator gives you 461.0303, which, when rounded to 3 significant figures as required, gives us 461 centimeters squared, because it's an area where you're going to use centimeters squared as our unit. We're given a lot more space to answer on the next page, but make sure to write down your answer in the correct space provided. 461 centimeters squared. Question 20 gives us the equation of a line as y equals 9 minus x, and the equation of a curve C as x squared minus 3xy plus 2y squared is equal to 0. We're told that L and C intersect at 2 points, and we're asked to find the coordinates of these 2 points, showing clear algebraic working. As I always do with any graph questions, I always draw a very, very quick sketch just to help me visualize the question better. Because this is a quadratic graph, it could look something like this, and our straight line is 9 minus x, so it would look something along these lines. We're told that L and C intersect at 2 points, which we've drawn into our sketch, and we're asked to find the coordinates of these 2 points. At points where 2 lines are intersecting, their y values are the same. This is actually a method used to solve simultaneous equations sometimes, and in a way this really is just another simultaneous equation. So we know that at the points of intersection, the y value is the same. Now what this means is, at the points of intersection, the y value in C is equal to the y value in 9 minus x. And this means that at those points of intersection, the y value, instead of writing y, we can write 9 minus x. So in reality, what we're doing is just substituting 9 minus x into the y values at C. Therefore, we can write C as x squared minus 3x times 9 minus x plus 2 times 9 minus x squared, and this is all equal to 0. Now we're left with a lot of algebraic expansion and cleaning up. X squared minus 27x plus 3x squared plus 2 times x squared minus 18x plus 81 is equal to 0. Now we have x squared minus 27x plus 3x squared. Then multiply this bracket by 2 to give 2x squared minus 36x plus 162 is equal to 0. And now we collect all of the like terms together. We can start with the x squareds, giving us 6x squared, and then the x values, which gives us minus 63x plus 162 is equal to 0. Dividing both sides by 3, we have 2x squared minus 21x plus 54 is equal to 0. And this can be factorized and solved to find the x values at these coordinates. This can be factorized to 2x minus 9 times x minus 6 is equal to 0, leaving us with the 2x coordinates. X is equal to 9 over 2, and x is equal to 6. Now to find the coordinates of these 2 points, we have to find the y values as well. And to do this, we substitute these x values into any of these 2 equations, although it's quite clear to see which one is easier to substitute into to find the outcome y values. When x is equal to 9 over 2, substituting into line L, which is 9 minus x, we're left with y is equal to 9 over 2. And when x is equal to 6, y is equal to 3. So these are our 2 coordinates. 9 over 2, 9 over 2, and 6, 3. Now that we're getting to the tail end of the paper, we should be prepared to encounter a lot more difficult problems, like the one we just did, and the last few as well. The question uses 3D trigonometry, showing us a cuboid ABCDEFGH, and we're told that for this cuboid, the length of AB to BC to CF is in the ratio 4:2:3. We're asked to calculate the angle between AF, which we can draw in, and the plane ABCD. Now keep in mind, this means the angle between AF and this bottom side, and not AB. So because we're told the ratios between some of these sides, we'll add in some variables for the lengths. We'll let AB be equal to 4x, and using these ratios, if AB is equal to 4x, BC must be 2x, and CF must then be 3x. We can draw in the construction line running from A to C, to form a right angled triangle, as we've got a right angle between these sides here. And by using Pythagoras' theorem, we have AB squared plus BC squared is equal to AC squared. Because AB is 4x and BC is 2x, we can square these to give us AC squared. So we have AC squared is equal to 20x squared. To get AC on its own, we just take the square root of both sides, leaving us with square root of 20x, which can be simplified to 2 root 5x. And we can mark that in. Next, remember that we want to find this angle AF, Next, remember we want to find the angle which I'll call FAC, and I'll denote this as A. And we can find this angle using trigonometry, because in relation to A, keep in mind that now we have a value for the opposite side and a value for the adjacent side. So we can use the tan of A. Remember that the tan of any x is equal to the opposite over adjacent. So the tan of A is equal to 3x over 2 root 5x. Cancelling the x at the top and bottom, and taking the inverse tan, we have A is equal to tan to the minus 1 of 3 over 2 root 5, which is equal to 33.854 degrees. And because we want the answer correct to one decimal place, we can round this to 33.9 degrees, which is our final answer. To simplify fully this algebraic fraction, we have to factorize the top and bottom first of all. By taking out the x in the numerator, we have x is equal to 6x squared plus 13x minus 5, which is a very factorable quadratic. And at the bottom, we can factor this out in difference of two squares pair. So we have 2x plus 5 times 2x minus 5. We can further factorize the numerator, giving us 3x minus 1 times 2x plus 5 all over 2x plus 5 and 2x minus 5. And the 2x plus 5 in the numerator cancels out with the 2x plus 5 in the denominator, leaving us with x times 3x minus 1 over 2x minus 5 as our fully simplified final answer. This is the penultimate question, so of course it has to be quite a difficult one. We're told that Boris has a bag that only contains red sweets and green sweets. Boris takes 2 random sweets from the bag, and the probability that Boris takes exactly 1 is 12 over 35. But we are given the original value of the red sweets to be 3 inside the bag. We're asked to work out how many green sweets there were originally in the bag, and of course to show our working clearly. So firstly, I will let the total number of sweets in the bag be equal to x. Because we have 3 green and we're told that because we have 3 red sweets, we're told that there's only red and there's only green. This means that the number of green sweets is equal to x minus 3, and red, of course, is equal to 3. Usually when it comes to any question where we're asked to take choices or taking things from anything, it's meant to be a tree diagram question with multiple branches. So we'll draw that out. This tree diagram represents the choices that Boris will take when he takes 1 sweet from the bag first and then another sweet. The 2 options he has are a red sweet, then a green sweet in the first choice, and in the second choice, a red sweet and a green sweet. Because the total number of sweets in the bag is x, and we know that the total number of red sweets in the bag is 3, we can write the probability of taking a red sweet first as 3 over x. However, if a red sweet is taken away, that means there will only be 2 sweets left in the bag for the second choice, and the total number has been reduced by 1, again because a sweet has been taken away. So the probability of taking a second red sweet after taking 1 red already is 2 over x minus 1. The probability of taking a green after that would be the number of green sweets, x minus 3, which is unchanged if you just take away a red, all over x minus 1, as the total number is x, but we've already taken away 1. The probability of taking green sweets is equal to x minus 3 over x, because that's the number of green sweets over the total. And similarly, the probability of taking a red sweet after that would be 3 over x minus 1, because there's 3 red sweets because there's 3 red sweets out of the x minus 1 which are remaining. And then for the final choice of green, we have x minus 4 over x minus 1. There's no need to fill out all of the branches in this tree diagram, because we're told the probability of taking exactly 1 red sweet. So in reality, you could only fill out this branch and this branch, but I've filled it all out for clarity. We know the probability of taking 1 red sweet is equal, using the AND rule for probability, the probability of taking a red first and then a green, plus taking a green first and then a red. And this is equal to 12 over 35. So the probability of taking a red sweet and a green sweet can be given by multiplying 3 over x times x minus 3 over x minus 1 plus x minus 3 over x times 3 over x minus 1. And multiplying these together, we have 3 over x minus 3 over x minus 1 plus 3 times x minus 3 over x minus 1 equal to 12 over 35. So because these two fractions have the same denominators, we can add them together, giving us 6 times x minus 3 over x times x minus 1 equal to 12 over 35. We found the green sweets to be equal to x minus 3 To be able to find x minus 3, we need to find x, and then take 3 away from that. So we have to take this algebraic fraction and solve for x. Firstly, it would be easiest to cancel the denominators by multiplying both sides by 35 times x minus 1. So removing the denominator, we have 35 times 6, which goes to 210 times x minus 3 on this side, times 12x times x minus 1. This can be expanded to give us 210x minus 630 equals 12x squared minus 12x. And all collected onto one side to give 12x squared minus 222x plus 630 equals 0. Dividing both sides by 2, we have 6x squared minus 111x plus 315 is equal to 0. Now, this might seem quite difficult to solve, but it can actually be factorized. This is done as 3x minus 45 times 2x minus 7, which gives us x is equal to 15, or x is equal to 7 over 2. However, we know that the number of green sweets has to be x minus 3. And if x is equal to 7 over 2, that means we would have a negative number of green sweets, which is impossible. Therefore, x must be 15. The number of green sweets is equal to x minus 3, which is 15 minus 3, which is equal to 12. And that's our answer. The final question in this paper is a functions question. It tells us that the function f is such that f of x is equal to 3x minus 2. And for the first question, we're asked to simply find f of 5. To do this, we replace all x with 5. So f of 5 is equal to 3 times 5 minus 2, which is just 13. Now, part B of this question is much harder, unfortunately. It gives us the function g such that g of x is equal to 2x squared minus 20x plus 9. We're given the function g such that g of x is equal to 2x squared minus 20x plus 9 for the domain x is greater than 5. And we're asked to find the inverse function g to the minus 1 in the form g to the minus 1x. When we're dealing with finding the inverse of quadratic functions, we must find a way of writing the function out in a form such that we only have one x written out. And this can be done by completing the square. So g of x is equal to 2 times x minus 5 squared minus 41. This is simply the function g of x written in x squared form. Now to find the inverse function, we have to let g of x equal to y. So we have y is equal to 2 times x minus 5 squared minus 41. And then switch x and y before we solve for y. So suddenly switch x and y together. We have x is equal to 2 times y minus 5 squared minus 41. And we must solve for y to find the inverse function. First of all, add 41 to both sides to give you x plus 41 is equal to 2 times y minus 5 squared. Divide both sides by 2 to give x plus 41 over 2 is equal to y minus 5 squared, and take the square root of both sides. To give y minus 5 is equal to the square root of x plus 41 over 2. Finally, to get y on its own, add 5 to both sides to give us y is equal to 5 plus the square root of x plus 41 over 2. And this is the inverse function, g minus 1 of x, written as 5 plus x plus 41 over 2 with the square root sign on top of it. And that is the paper finished. Hopefully, you'll end up with 100 marks. Thank you so much for watching this video. If you found it useful in any way, make sure to leave a comment, and I'll make sure to upload content similar to this in the future, more catered towards direct exam results. Make sure to like and subscribe, and I wish you all good luck for any mock exams or for your real GCSE exams whenever they come. Thank you so much for watching.